So the matrix S corresponds to the table for January. This here is these are the sales for Sammy, and these here are the sales for Jenny. It's exactly like in the table. So if we want a matrix to represent the sales in February, we just literally copy out the table but in a matrix form. So it's a 3 by 2 matrix, and the first column 32, 24, and 12, and the second column we have 19, 20, and 25. And that is our matrix M. This is part A. For part B, they ask us to evaluate M minus S. And this is something that we are familiar with. And without showing all the working, you should be able to tell 32 minus 23 is 9. 19 minus 17 is 2. 24 minus 12 is 12. 20 minus 26 is negative 6. 12 minus 25 is negative 13. And 25 minus 15 is 10. So that is M minus S. What do the elements of M minus S represent? So what we actually did was we took the second table minus the first table, and we were actually subtracting corresponding values. The 32 minus 23, the 19 minus 17, and so on and so forth. So what this matrix represents, or at least this 9 here, it represents the difference in Sammy's sales of model A between February and January. So this is still, if I may add down here, this is still model A. This is still model B. This row still represents model C. This column still represents Sammy. This column still represents Jenny. But now the elements represent a difference in their sales between January and February. So you would write that out. Okay, here I've shown the answer to part C. M minus S represents the difference in sales for each model by Sammy and Jenny between February and Jan. Now we go on to part D, and they ask us to write down a matrix D such that the product DS will show the total amount of sales for each person in January. We can tell, and you can probably guess, that 20, 30, and 50 go into a matrix. But the question is it a row matrix or a column matrix? And really, the best way to find out is just to write it down and to see if it works. And in this case, I have chosen a row matrix. I don't need to do so. The question doesn't actually ask me to find DS, but I'm going to show DS to prove to you that my matrix D is correct. So I have D here, my matrix D. I have S, from the earlier part. And when I multiply it together, I think what you will see is that, if I multiply it, I have the 20 multiplied by 23. So that is 20 multiplied by 23 is 460, plus 30 times 12, which is 360, plus 50 times 25, which is 1250. Okay, that's for the first row. That comes from matching this row to this column. Now I match this row to this column, and then I have 20 times 17, which is 340, plus 30 times 26, which is 780, plus 50 times 15, which is 750. Okay, and this is exactly what we want, because here 460 plus 360 plus 1250, this is the total amount that Sammy would have made from selling model A, model B, and model C. And And through the matrix multiplication, we've actually added all the three numbers together. So once again, this is the sales by Sammy, and this would be actually, if you have noticed, the sales by Jenny. You can evaluate the matrix, which I will not do now, but this goes to show that indeed my matrix D was correct after all. So this here is correct. Carrying on to our last part, now we are evaluating ME. They have given us E. I have shown you the calculation here, but I have purposely included this step inside here. So you can see that the effect of this matrix E is to allow us to add 32 and 19, 24 and 20, 12 and 25. Basically, we're adding up the rows in the matrix. If I may highlight down here, what we are doing is that we are actually adding up this, followed by this, and then finally this. We are adding them up, and we get 51, 44, and 37. And what you may have observed is that this here is Model A, Model B, Model C. We're actually looking at the total sales from both Sammy and Jenny, but for the month of February. And so this completes part E.